OSHA has no specific regulation prohibiting the use of metal boxes for outlets on extension cords. However, OSHA may cite employers for violations of the General Duty Clause, Section 5(a)(1) of the Occupational Safety and Health Act of 1970 if the metal box poses a hazard to employees. The National Electrical Code, NEC, does not prohibit the use of metal boxes for outlets on extension cords. However, Section 400.9 of the NEC does state that extension cords shall not be used as a substitute for permanent wiring. While not specifically prohibited, using metal boxes for outlets on extension cords is not considered a best practice for the following reasons. Firstly, grounding is a concern because metal boxes are not typically grounded, which can pose a shock hazard if the extension cord's ground wire is not properly connected. Secondly, corrosion can occur because metal boxes can corrode over time, especially if exposed to moisture, which can weaken the box and create a potential hazard. Thirdly, durability is a factor because metal boxes are more susceptible to damage than non-metallic boxes, which can compromise the safety of the outlet. Instead of using metal boxes for outlets on extension cords, it is recommended to use non-metallic boxes. These boxes are approved for use with extension cords and are typically made of plastic, rubber, or fiberglass. Extension cords should be equipped with a 3-prong plug with a grounding pin to ensure proper grounding. If the extension cord will be used in areas with moisture, a ground fault circuit interrupter, GFI, should be used to prevent shock hazards. While the use of metal boxes for outlets on extension cords is not specifically prohibited by OSHA or the NEC, it is not considered a best practice and can pose safety hazards. Electricians should use non-metallic boxes, grounding plugs, and GFI protection when using extension cords to ensure the safety of employees and others. Let's delve into the specifics of each of these points to provide a more comprehensive understanding. Firstly, the grounding issue with metal boxes is paramount. In electrical systems, grounding provides a low resistance path for fault current to flow back to the source, trapping the circuit breaker or fuse and quickly disconnecting the power. This prevents dangerous voltage from appearing on conductive surfaces that people might touch. Metal boxes, when properly integrated into a grounded wiring system, can provide this safety feature. However, the issue arises when using metal boxes on extension cords because the grounding connection is often compromised or non-existent. Extension cords are frequently used in temporary setups where proper grounding is not always assured. If the extension cord's grounding wire is not securely connected to the metal box and back to the grounded electrical panel, the metal box can become energized during a fault, posing a significant shock hazard. This is particularly dangerous in damp or wet environments where the risk of electric shock is greatly increased. The absence of a reliable grounding path negates the safety benefits that a metal box would otherwise offer in a permanent wiring installation. Secondly, corrosion is a long-term concern that can degrade the integrity of metal boxes. Over time, exposure to moisture, humidity, and corrosive substances can cause metal boxes to rust and weaken. This corrosion can compromise the structural integrity of the box, making it more susceptible to damage and potentially exposing live electrical components. In addition, corrosion can affect the grounding connection, further increasing the risk of electric shock. The presence of corrosion can also make it difficult to properly secure the outlet within the box, leading to loose connections and potential arcing. While corrosion-resistant metal boxes are available, they are not always used in extension cord applications, and even these boxes can corrode over time if not properly maintained. Non-metallic boxes, on the other hand, are inherently resistant to corrosion, making them a more durable and reliable option for extension cord applications. Thirdly, the durability of metal boxes is another factor to consider. Metal boxes, while generally sturdy, can be dented, bent, or otherwise damaged if subjected to impact or abuse. This damage can compromise the safety of the outlet and increase the risk of electrical hazards. For example, a dented metal box may have sharp edges that can damage the insulation of the wires inside, leading to a short circuit. A bent box may not properly support the outlet, causing it to become loose and create a potential fire hazard. Non-metallic boxes are typically more resistant to impact and are less likely to be damaged in the same way as metal boxes. They are also less likely to conduct electricity if damaged, further reducing the risk of electric shock. Given these concerns, the use of non-metallic boxes is strongly recommended for extension cord applications. Non-metallic boxes are specifically designed for use with extension cords and offer several advantages over metal boxes. They are typically made of plastic, rubber, or fiberglass, all of which are non-conductive and corrosion-resistant materials. This makes them a safer and more durable option for use in a variety of environments. Non-metallic boxes are also lightweight and easy to install, making them a convenient choice for temporary wiring setups. In addition to using non-metallic boxes, it is also essential to ensure that extension cords are properly grounded. This means using a 3-prong plug with a grounding pin and plugging the extension cord into a grounded outlet. The grounding pin provides a direct connection to the grounding system, ensuring that any fault current will safely flow back to the source and trip the circuit breaker. It is important to inspect extension cords regularly to ensure that the grounding pin is intact and that the cord is not damaged. Damaged extension cords should be repaired or replaced immediately to prevent electrical hazards. Furthermore, the use of a ground fault circuit interrupter (GFI) is highly recommended, especially when using extension cords in areas with moisture. A GFI is a safety device that monitors the current flowing through a circuit and quickly disconnects the power if it detects a ground fault. A ground fault occurs when current leaks from the circuit to ground, which can happen if someone touches a live wire or if there is a fault in the wiring. A GFI can detect even small ground faults and trip the circuit within milliseconds, preventing serious injury or death. GFI are particularly effective in preventing electric shock in wet or damp environments such as bathrooms, kitchens, and outdoor areas. They are also recommended for use with power tools and other equipment that may be used in potentially hazardous conditions. In conclusion, while the use of metal boxes for outlets on extension cords is not explicitly prohibited by OSHA or the NEC, it is not considered a best practice due to the potential for grounding issues, corrosion, and damage. Electricians and other professionals should prioritize safety by using non-metallic boxes, grounding plugs, and GFI when working with extension cords. By following these recommendations, it is possible to minimize the risk of electrical hazards and ensure a safe working environment for everyone. It is also important to remember that extension cords are intended for temporary use only and should not be used as a substitute for permanent wiring. If permanent wiring is needed, it should be installed by a qualified electrician in accordance with the NEC and local electrical codes. Regular inspections of electrical equipment and wiring are essential for identifying potential hazards and preventing accidents. By taking these precautions, it is possible to create a safe and reliable electrical system that meets the needs of the workplace while protecting the health and safety of employees and others. Now, let's elaborate on the specific sections of the NEC that are relevant to this discussion. Section 400.9, which states that extension cords shall not be used as a substitute for permanent wiring, is a fundamental principle of electrical safety. This rule is in place because extension cords are not designed to handle the same loads or withstand the same conditions as permanent wiring. Using extension cords as a permanent wiring solution can overload the circuit, overheat the cord, and create a fire hazard. Additionally, extension cords are more susceptible to damage and wear than permanent wiring, increasing the risk of electrical shock. If permanent wiring is needed, it should be installed by a qualified electrician in accordance with the NEC and local electrical codes. This will ensure that the wiring is properly sized, installed, and protected, providing a safe and reliable electrical system. Furthermore, the NEC contains numerous other requirements for the installation and use of electrical equipment, including requirements for grounding, overcurrent protection, and wiring methods. These requirements are designed to prevent electrical hazards and ensure the safety of people and property. It is important for electricians and other professionals to be familiar with the NEC and to follow its requirements carefully. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. In addition to the NEC, OSHA also has regulations that address electrical safety in the workplace. OSHA's electrical safety standards are based on the NEC and provide specific requirements for the safe use of electrical equipment and wiring. These standards cover a wide range of topics, including grounding, wiring methods, and the use of personal protective equipment. OSHA's electrical safety standards are designed to protect employees from electrical hazards in the workplace. Employers are required to comply with these standards and to provide a safe working environment for their employees. Failure to comply with OSHA's electrical safety standards can result in fines, penalties, and other enforcement actions. It is important for employers to be familiar with OSHA's electrical safety standards and to implement a comprehensive electrical safety program. This program should include regular inspections of electrical equipment and wiring, training for employees on electrical safety procedures, and the use of appropriate personal protective equipment. By taking these steps, employers can reduce the risk of electrical hazards in the workplace and protect the health and safety of their employees. Now let's consider the specific scenario of using metal boxes on extension cords in different environments. In dry environments, the risk of electric shock is generally lower than in wet environments. However, the potential for corrosion and damage to the metal box still exists. Therefore, even in dry environments, it is recommended to use non-metallic boxes and to ensure that extension cords are properly grounded. In wet environments, such as bathrooms, kitchens, and outdoor areas, the risk of electric shock is significantly higher. Water is a good conductor of electricity, and even a small amount of moisture can create a dangerous electrical path. Therefore, in wet environments, it is essential to use GFI to protect against ground faults. GFI are designed to quickly disconnect the power if they detect a ground fault, preventing serious injury or death. In addition to using GFI, it is also important to use waterproof or water-resistant boxes and fittings to protect electrical connections from moisture. These boxes and fittings are designed to prevent water from entering the electrical system, reducing the risk of corrosion and electrical shock. Furthermore, it is important to avoid using extension cords in areas where they are likely to be exposed to standing water or other sources of moisture. If it is necessary to use extension cords in these areas, they should be elevated off the ground and protected from contact with water. Finally, let's discuss the importance of proper maintenance of electrical equipment and wiring. Regular inspections of electrical equipment and wiring are essential for identifying potential hazards and preventing accidents. These inspections should be conducted by qualified personnel who are familiar with the NEC and OSHA's electrical safety standards. During these inspections, electrical equipment and wiring should be checked for damage, wear, and corrosion. Any damaged or worn equipment should be repaired or replaced immediately. In addition, electrical connections should be checked for tightness and corrosion. Loose or corroded connections can cause arcing and overheating, which can lead to fires. Furthermore, electrical panels and boxes should be kept clean and free of debris. Dust and dirt can accumulate inside electrical panels and boxes, creating a fire hazard. Regular cleaning of electrical panels and boxes can help to prevent fires and ensure the safe operation of electrical equipment. In conclusion, electrical safety is a critical concern that requires careful attention to detail and a thorough understanding of the NEC and OSHA's electrical safety standards. By following the recommendations outlined in this discussion, it is possible to minimize the risk of electrical hazards and ensure a safe working environment for everyone.